Okay, so hello everyone, welcome. Can you hear me?
Yes, sir.
Okay, thank you. Just we're waiting 1 minute for joining. In the meantime, I also give you an announcement for our upcoming online training program, mainly which will be start from the 14th June. From next week, our next test training will be start. So if you want to join this online training program, simply contact in this WhatsApp number and also contact with this email. So basically, in this online training program, you will learn all of those things from beginners to advanced level on Google Earth Engine. If we have no knowledge about the Google Earth Engine or JavaScript or Python or any programming language, not about that, you will learn all of those things from beginners to advanced level on Google Earth Engine. So here you can see all of course content. All of those things I already added in the video description. You can simply check it. And if you want to join this live training program, then you can also get some benefits, such as you can get that course e-certificate after submitting all of assignment. You can get the materials, mainly slide PDF. You can get all of practice code, also get that all of recorded class. If you miss any live training session, then you can easily cover it using the recorded class. And you also get the lifetime teaching support. So it's very important as a beginners, because when you want to learn the Google Earth Engine platform, you face a lot of problem. So that's why you need the continuous support. So after completing the total 7 days live training program, you also get the lifetime teaching support regarding this online training program. So if you want to join this online training program, simply contact in this WhatsApp number, also contact with this email, then complete your registration. Thank you. Okay, so we'll start today's session. So basically today is our seventh number of class, and basically today I talk about that change detection analysis, how we can easily perform using Google Earth Engine. It can be vegetation change detection or land use land cover change detection or any other change detection, how we can easily perform. As well as we also talk about that hyperparameter turning, how we can easily find out that best number of piece values. So let's go try to start. So let me share my screen. Okay, can you see my screen? Is it visible? Okay, so basically today I talk about that how we can easily perform with that land use land cover change detection in Google Earth Engine. Then how to make the NDVI change detection, then how we can easily show the class-wise land use land cover change detection in one layer in Google Earth Engine, and also talk about that hyperparameter turning or improving the accuracy of your machine learning model. So let's go. So here you can say already, yeah. So here I already write the code for one land use land cover classification map. So basically, I already created this map for the 2 decade. One is that land use land cover map for 1991, another is the 2021. Okay, so this is the map I already created. So now from here I will show you that how we can easily make the change detection, mainly how much area will be increasing for that 2021, how much urban area. Okay, so we try to find out the change detection. So this is my one kind of map. This is the result for 1981, and this is the another for the 2021. Okay. Between the two decades, we try to find out that change detection analysis, and also find out that transition area, and also make the change detection map between these two maps. And how I can create this map? Same process which I already show you that previous class using the machine learning model in Google Earth Engine platform. How we can easily make the map? Same process. In this time, I will say apply in here, and then create this type of imagery, land use land cover map. So here you can see. First of all, this is the image for 2021 for Landsat imagery. So for this Landsat imagery, we take all of training sample for 2001 individual or water, build up, vegetation, others mainly it's barren land. Okay, so all of training sample we take for the 2021, and then make the land use land cover map for 2021 using the Landsat image 2021. And further, this is the image for Landsat 1991. From this imagery, you also take the training sample for water, also take the training sample for build up, then vegetation and others. And further, we are just use these things and make the land use land cover map for 1991. Here you can see we can get two map. One is that 1991, another is the 2021. So this is the result for that. So mainly this red color identify about that build up, and yellow is identified for that barren land, green is the vegetation, and blue is the water body. And also you can see about that 2021, same red color identify about the build up or settlement, green is identify about the vegetation, and this is that mainly blue for water, yellow for barren land. So let's go try to start one by one. And this is the code about that. I will also send you this code, then you can easily get it how it will work for that. At the same time, 2 decade land use land cover we create. So now in this time change detection analysis. So basically we can take the two types change detection. One is that single class change detection, another is the multi-class change detection. So single class change detection, basically it's only for the one class. Suppose you want to make the change detection only for the build up or urban area change detection. How much build up will be increasing or how much build up is decreasing. So this type of things when you want to do, then it's called the single class change detection. Or you can put any other single class. Suppose only for the vegetation change detection or water body change detection or any other single class. So in this example, I will show you for that urban change detection, mainly urban or settlement, how much it will be increasing between this two time period. We try to find out this result. So first of all, here you can see, in this time we try to calculate it that how much build up area are available for the year of 2021. So this is our map, LULC map 2021. So from this map, we calculated how much area of build up in available for this area. Okay, how much build up area is available. So first of all, we need to calculate the single class area of 2021, how much area is available for that. So this is the map I already created, and this map is already stored in a variable. So this variable you have to find out. So here you can see, so this is the map. Here you can see classified RF 2021. So this variable is stored this map for 2021, and also you can see 1991. So this map is stored this variable classified RF 1991. Okay. So in this time, I want to calculate it how much area are available in 2021. This map 2021, and this is the variable stored in here. And also you can see about that you can see about, simply click on here, then you can get about that value. Suppose here you can see water is the 0, then also you can see about that build up, it's 1. Okay, then you can see about it 3, then 4. Also for 2021 it's a 0. Okay, it's for another year. Also you can see about that build up, it show about the value for 1. Okay, so then also you can see about the vegetation is that 2, then 3. So this is the value about that. So now I want to calculate it how much build up area are available in my study area, in my land use land cover map 2021. So further I simply copy this variable name, and you can see I already write the code in here. So further, I simply copy this variable name and paste here and set equal to 1. Why I put here the 1? Because you can see here my build up 2021, this value is the 1. Okay, so this value is the 1. So in this time, I want to make the single class map of build up area. Further, I want to calculate it how much build up area are available in my study, in my map. So here you can see just I take a variable, suppose build up area 2021 equal, then call this classified RF 2021. So basically this variable is stored this map. From this map, I just choose only for the one class. This class value is the 1. Because when I take the training sample, I put the water is the 0, build up is the 1, vegetation is the 3, other is the vegetation is the 2, other is the 3. Serially, I put here the 0, 1, 2, 3. So now I put here the 1. So now what happened? So now this variable is stored only for the build up area class. Suppose I can got only for the build up area. This variable is stored only for the build up area. Because in this time, I just simply call my land use land cover map 2021 and set equal to, its EQ means equal to 1. 1 is the value of build up. Okay. So now it is stored only for that your build up area result. So now we try to add this map. So using the map.addLayer function, call this object name. Okay. And further, we are just put here the mean is the 0, max is the 1, and gray and red. So basically in this time when I run the code, gray, it show the gray color. How you find out the gray color? It show about that there is no urban, and red color identify about the urban. Okay. So now click there and check the result about that. In this time it create the another layer which show the result only for the urban map of 2021. Okay, you can see this is the layer name. I put the layer name is the urban 2021. So that's why it show about the urban 2021. So now it display the result for urban 2021. Okay, it's working out. So here you can see in this time, other class, mainly this type of gray color identify about the other class. Other class show as a gray color. Okay, in this time it show only for the red color, which is indicating the urban area or build up area. We can get that. Okay, and other class show as the gray color. So it's only for the single class map. Okay, so this is the process when you create any single class map. Suppose you want to make the water body map in 2021. Suppose here you can see this is the water body. You need only for this water body map for this region of interest. So what you can do, just change the variable value name. You can see for the water, what is the value? For the water, value is the 0. So just put here the 0 equal to 0. And then put here the, suppose I want to show the water body as the blue color, put here the blue. Click the run. So now it show the result for water body map for this study area in 2021. So it working. So now it create the water body map. And using this process, you can create any single class map. Further, just change the detection between the single class. So now I can see it's only for the water body map. Okay, so other class show as the grayscale color, and now we can get the only one class which is the blue, is indicating the water body. Okay, this is the process when you want to make any single class map. It can be water body or urban or build up or vegetation. Just simply change the value. Okay, so in this time we can talk about the build up. So just I put here the build up value is the 1, and I'm to show the build up area is the red. So just put here the red. Okay, so now we can get that urban map 2021. So click to run. It show the result urban map 2021. Further, I want to calculate it. Suppose how much area are available for the urban 2021. So this is the process you can see about that. So for that, what we can do, just take a variable. Suppose I put the variable name is the urban area and call this build up area 2021, because this variable is stored only for the one class of urban or build up. So this thing I simply call and multiply with this function, which is e.image.pixel area. So basically this function calculated the pixel area in square meter unit. Okay, so this variable is stored the one class which is urban, and now I want to calculate the value of urban, how much area. For that, simply call this variable name and multiply with this function. Okay, so after doing these things, just I calculate the value. For calculating the value, we are just use the same process, which is called the reduce region. So you can see, so just I take a variable area urban 2021 and call this urban area and put a function reduce region. So we already know about the reduce region function. So basically, when you want to calculate any specific boundary, any pixel value, total pixel value, or average pixel value, or median pixel value, or standard deviation pixel value, then we have to use the reduce region function for a specific boundary. So for that, after calculating this function, I just simply call this urban area and put here the reduce region function. And further, I want to calculate the total area of urban. So use here ee.reducer.sum. And geometry, it's my shapefile boundary variable name, which is AOI. And scale is the 30 meter for. And this time I use here the Landsat imagery. So further, click to the run. So now it shows the result about that your total urban area in 2021, how much area? We got the result in square meter unit. So you can see it computed in here. So here you can see it show the click on here, then we can easily get the result. We can get the result in square meter unit. So that's why it look like that. So further, we can easily convert it into a square kilometer. So how we can convert the square kilometer? So for that, just I take a variable. Suppose urban area 2021 square kilometer. You can put any variable name, and it's a number, and this number key value classification. Okay, so just I simply put the e dot number because it's a number, and this number is stored in a variable. What's the variable name? Urban area urban 2021. So I call the area urban 2021, and you can see this number get from classification. Okay, classification is the key value keyword. Okay, just I put here the get and put here the classification. This same name which you show in here, classification. Then I put here the classification. Further, divide with 1 is 6, then we can get the result in a square kilometer unit. And you can see I also put here the round function. Round function mainly show the result only for the integer value, only for show the round figure. So click to the run and also print this result. So for that, simply print. Click to the run. So now it show the result in square kilometer as a round figure because I put here the round function. So here you can see you can get this result in here 75 square kilometer. Okay. So after converting to square kilometer divided 1 is 6 and also put it the round function, then we can get the round figure of this. So it shows about the 75 square kilometer area in 2021. We find out this result. Further, the same process we also do for that 1991. Okay, same process. We are just applying this for this map. So in this time, we are just calculating the urban area from this map. So first of all, just simply make the single map of the urban in 1991. Further, calculate the area. Same process. So for that, just take a new variable. Suppose build up area 1991 and call this variable name. So basically, this variable is stored this map. Okay, and equal to set the value of this urban or build up. And further, just I want to display this result about that. So just map.add layer and call it. So in this time, the build up area showing 2019-91 as a red color, single class map. So click the run. So now it creates the map of urban into 1991. Another layer you can see urban 1991. So you can see it create this map look like that. In urban 1991, we find out only for this place is the urban. Okay, and you can see this is the result for 2021. Okay, so this is the urban map in 1991, and this is the urban map in 2021. You can see a lot of urban expansion. Okay, so this is the process about that. Now I want to calculate that how much urban area in 1981. Same process. We are just taking another variable. Suppose urban area, then call this variable name and multiply with this function, and further just calculate the total area of the urban. So just put here that reduce region function and calculate the total area of this urban. Just I uncheck this one and print this area. Then we can get the result in square meter. Further we convert into square. So just take a variable. Just okay. So now it's running. Yeah. Now it's about that how much urban in 1981. In 1981, we find out that you can see only for the 5 square kilometer area. Okay, so this is the result for this map. We find out that 5 square kilometer area of urban in 1981, and you can see that in 2021, find out that 75 square kilometer. Okay, in 2021, this is the result for 2021, and this is the result for 1981. Okay, so 70 square kilometer area increased for the urban between these two time period. Okay, so after calculating these things, okay, so here you can see we can get the two result. One is that 75, another is the only 5. So we find out that 70 square kilometer area is the increasing, and you can see about this map. This is the map for 2021 result, and this is the map for 1991. Okay, you can see, and you can see this is the result for 2021. So now I want to make the change detection between the two class. Suppose urban 1991 and 2021, how much area? Changed and unchanged between the only one class, not multiple class. Further, we talk about the multiple class change detection. In this time, we are just find out that only for the single changed, only for the urban changed map. Okay, suppose I take a variable urban changed map and then call the build up area, subtract with 2021 and subtract with build up area 1991. Okay, simply subtract these two things. One is that build up area 2021, another is that build up area 1991. And further we check the changed map. So click to the run. Here yellow is show about that unchanged area of urban, and red is the change of urban. Okay, yellow means that there is no change, and red show about the change. Okay, so here you can see about that. So now we can get this type of things. You can see basically this type of yellow color identify about that unchanged area. Okay, there is no change between these two time period. Only for the single class urban. In this time we talk about only for the urban. There is no change about the urban. Okay, and this type of things, this type of area is the changed and create the new urban area. So here you can see in this time here you can see it show about the yellow color because in 1991 we find out it's the urban. Okay, and 2021 is still it was the urban. It is urban. So there is the no changed. You can see we can find out the urban or build up area in 1981, and 2021 we also find out that build up area. So it's not changed. So that's why when I can make the change map, then it show about the yellow color, because there is no change. We find out the new urban class. We find out this type of red color pixel will identify about the new urban. We can find out in here. Okay, and how much area we can get for the new urban? We already calculate it's the 75 minus 5, 70 square kilometer urban. So in this time we can find out this map, how much area, 70 square kilometer area increased for the urban in 2021. Okay, so this is the process about that, how we can easily make the only for the change detection, only for the one class. Suppose it can be your urban class or water body class or any other specific one class. When you want to make, just apply this process. But when you apply the multiple class change detection at the same time, suppose at the same time I want to make that all of classes change detection. So further we have to follow some step. So for multiple class change detection, we have to first step is the reclassify. We have to reclassify. It's a one step. Reclassify mainly here you can see I just put here the 0, 1, 2, 3. And when I put the reclassify, then 0 will be 1, 1 will be 2, 2 will be 3, 3 will be 4. Okay. And for because we also need the reclassify for another purpose, because we have to put the another formula. So that's why we have to reclassify. So reclassify, how I can reclassify? Reclassify mainly, suppose this type of value, suppose water is the 0, I convert into 1. Build up is the 1, it convert into 2. Its vegetation is the 2, it convert into 3. Okay, so just 0 will be 1, 1 will be 2, 2 will be 3, 3 will be 4. Okay, so we first step is the reclassify 0 to 3 into 1 to 4 for land use land cover map 2021 and 1981. Both of map we just reclassify. So for the reclassify, just we take a variable, suppose before class. I just take a variable before class, and we call the map of before class 1981 and use the remap function. So basically this function help you to reclassify from 0 to 3 to 1 to 4. So just call this land use land cover map. So this in this time this map is stored in this variable classified rf 1981. I want to reclassify, so that's why use the remap function. And further, this is my previous value. Okay, this is my previous value, and I put the new value, look like that. Suppose in this time previous value 0, but now I put the 1. Okay, then 1 will be 2, 2 will be 3, and 3 will be 4. So 0, 1, 2, 3, it's my previous value, which I put in here 0, 1, 2, 3. So this value I simply reclassify using the remap function and put here the previous value and then put here the new value. Okay, so now this variable before class, it stored that water is 1, build up is 2, vegetation is the 3, and others mainly barren land, it's a 4. Okay, it is stored in here. Further, same process for the 2021. Suppose I take a variable after class and call this map, which is stored in the 2021. This map, I call this variable name classified RF 2021. It is stored in this map, and I want to reclassify. So put here the remap, and then 0, 1, 2, 3. It's my previous class, and I put here the new value 1, 2, 3, 4. Okay, and it's stored in here. Okay, so okay, anyone any question? Yeah, I already share. We have put a equation. Okay, so for that we have to reclassify. Yeah, I will go to further just a minute. Okay? So we have purpose to reclassify. So we have to put a equation. So that's why we need to reclassify. First step. And these things we also use the further step. So here you can see step by step, then you can easily get that idea. Okay. So here you can see before class and after class. This variable mainly stored the two things. Mainly all of reclassify value. Suppose water is the 1, then build up is the 2, vegetation is the 3, and others is the 4. So we are just make the reclassify because we need it further when I calculate the transition. Okay. Okay. So now I calculate the change between that before class and after class. So just I simply call that after class, basically it's our 2021, and before class is the 1991. Okay, just simply subtract these two things, after class and before class. Okay, just simply two things. I simply subtract, and now it show about the overall changed and unchanged area between these two time. Overall changed all of classes. So just we try to find out this map and click the run. So now it show the result overall change. Okay, not any specific classes, but we also try to find out that specific classes. Then this time, where you find out the red color, it's indicating that changed. This area is the change, and white color identify about that unchanged area. Suppose in 1981 it was a vegetation, at the same time it was a vegetation, so it show about the white color. Suppose in somewhere where you find out that in build up area it's also same, also some of the build up area, so it's the unchanged area. So in this time we can get this type of map. So it mainly show the about overall changed, all of classes overall change area about that. Okay, and now I want to calculate the transition. Suppose how much area increasing or decreasing, how much area about that, we try to calculate these things. Okay, double slash mainly it's your comment. Okay, when I just delete this, then it will be deleted, or just simply select and press Control and Shift. Yeah, please.
Can you explain once again? I missed when you talked like what is the red color for and what is the white color for?
Okay, so in this time we can get this type of class. Here you can see. Okay, so it's about the before after class and before class. We just simply subtract these two things, and now it show about the changed area, changed and unchanged area. So basically in this time we can get this type of red color identify. Basically it show about the changed area. So this type of classification, it show about the change, and we have to also mention about that. Suppose not equal to 1. Suppose I just put here and try to check about that. Okay, so I can see it show about this type of totally this type of color. Okay, in this time not equal to 1, it indicating about that one class mainly. Suppose it's suppose only for that water. Okay, it's a water not equal to 1. Oh, just I put it the not equal to 0, and then okay. Okay, so now it's perfect. Yeah, so now it's perfect. We have to put here the not equal to 1, sorry, not equal to 0. Okay, then in this time this map show about that this type of red color identify about that changed area. Suppose this type of things, this type of area will be changed. Suppose it can be vegetation or it can be barren land, but this type of land it changed in the 2021. So this type of things you can see this type of red color, all of red color is the change in 2021. But white color, suppose it's still same area, suppose unchanged area. Suppose it show about that vegetation at the same time 2020 we also get the vegetation. So there is no change. Okay, and this type of red color identify about the changed area. Suppose here you can see in the middle place it was build up area. Okay, in the middle place we're gonna check about that other map, we find out the build up area. In 2021 we also find out the build up area again for this place. So there is no change, but other place also expand the build up area or urban area. So that's why you can get this type of red color. Okay, So you mention about the not equal to 0, and further we can get this type of map. It show about the overall changed and unchanged map. So this type of red color identify about that all changed area, and this type of white color identify about that unchanged area. Okay, this type of area is not changed. This type of white color identify about the unchanged area, and red color identify about the changed area. Further, you also calculate the area. Suppose how much area will be changed and unchanged. It's the total class. Okay, not for a specific any classes. Okay, so any question, please? Any doubt? Okay, any doubt now?
Sir,
Yeah, please.
how to perform change detection class by class?
Yeah, I will go to the step by step. Okay, I will show you that step by step. So in this time, you can just any problem for that overall changed and unchanged area. It show about this map mainly show the result for overall changed and unchanged area. So here you can see about that. I will show you that one by one. So first of all, we try to find out that change detection only for that one class. Okay, only for the one class. So for that, what we can do, first of all, we try to, you can see, make the map for urban map 2021. So this is the map for urban 2021. Further, we calculate the urban map in 1991. We can get this type of map here, you can see. So we find out the urban, this place. And 2021 also have this urban, you can see. There is not change. Okay, we can get this place. You can look at this place. We can get this. There is not change. There is not change area. Okay, so in this time we can say that it is a unchanged area. Okay, because in 1991 we find out the build up, and 2021 we also find out the build up. So there is not change. But other year you can see in this time there is no build up in 1991. But 2021 we find out the lot of build up area in this type of region. So it changed. So here when I put the urban change map only for that, we can get this type of map. Okay, you can see here this place is totally unchanged because there is no change. But when I put the unchanged map, then we can get this type of build up is the new. We can find out in the 2021 this type of build up. And the same process we are also applying here. So just we try to multi-class, all of class considering this time, all of class. It can be build up, vegetation, parent land, all of class. We try to find out that overall changed and unchanged map. So here you can see for that we can find out white color identify about that there is no change, and red color identify about the changed area. So it can be changed to build up or vegetation or anything, any class can be changed. It show about that overall changed and unchanged map. Further we discuss about the class wide change detection one by one. Okay, so I hope you can easily got this. Yeah. So now we talk about the transition area, how we can easily calculate the transition area. Transition area means that suppose water to water, how much area? Suppose water to build up, how much area? So transition means that suppose in 1991, suppose water, how much area water convert into build up area? How much water convert into that vegetation? Okay. So this type of things we calculated, it called the transition. So first of all, for transition, so we have to use this formula. So here you can see, and for using this formula behind the another thing. So I'll show you the explain just a minute. So just I take a variable March and call the before class. Before class mainly 1991. Okay, before class mainly 1991. Multiply with 100, add with after class. After class mainly 2021. Okay, so you can see I just put at the before class, multiply 100, before class mainly 1991, after class mainly 2021. So multiply 100 and then add with that. And I put the rename is the transition. So after printing these things, you can see what can get from here. So run the code. So now it show about this result transition. So it computing. Okay, so click on here. Here you can see the result. Look like that. Here you can see bands. So here you can see you can get the transitions. This is our name. This I put in here. You can say I put the name in the transitions. So this same name you also put the transition. It's a integer value belongs with 101 to 404. So it means that it including that 101, 102, 103, 104. Then 201, 202, 203, 204. Then 301, 302, 303, 304. And finally 401, 402, 403 and 404, all of values including in here. Okay, and now what is the meaning about the 101, 404? So you can see before class, before mainly you can see here in my formula, before class multiply 100 and add the after class. So in this time 1 is the before class, okay, and 0, and this one is the after class. Okay, and now I already make the reclassify. So now 1 is water. So water in 1991, and this water means that water in 2021. Same process. Suppose 102, 1 is water and 2 means build up. Okay, build up. So now I can see about that. What is the meaning about that 101? So basically you can see 101. It means that water 1991 to water 2021, how much area? Water 1991 to build up how much area? 2021. 103 means that water to vegetation 2021. 104 means that water to barren land how much area? Then 201 means that build up to water how much area? Okay. Then 202 means that build up how much area in 2021? Then build up 1991 to vegetation 2021 how much area? So it means that it has, we create this type of things, this type of transition. So for that, first of all we reclassify, and then we are just put this formula, this type of formula. Okay, before class multiply with 100, add with after class. Then we can generate this type of transition class 101, 102, 103. Then 201, 202, 203 and 204. Then 301, 302, 303, 304. And finally 401, 402, 403 and 404. So all of those things we try to put in here. So this is the transition between that. So we find out the transition. And now further we calculate the area. Suppose water 1981 to water 2021, how much area? Water 1981 to build up area, build up 2021, how much area? So all of those things we calculated, and these things called the transition area. So, and we already make this variable merge. So basically you can see all of things 101, 102, 103, it is stored in this merge variable. Okay, it's stored in the merge variable. So let's check, we try to calculate transition area. So also 404, all of those things. I hope you can easily get this idea. 101 means that. Okay. So 102, 103, all of those things stored in here from 404, all of things. Okay. So now we try to calculate these things. We have to use the transition matrix and calculate the frequency histogram to calculate the pixel. Okay. Pixel number. How much pixel convert one class to other class for the different 2 time period. So for doing these things, we are just take a variable that was transition matrix, and I call the merge, and then put it the reduce region function. This function mainly calculate the, in this time we calculate the frequency histogram. So what is the frequency histogram? It calculates the pixel number per class transition. So just call the reducer, and I want to calculate the reducer frequency histogram. So basically it calculates the pixel number, and this is my study area, geometry AOI, and I put here that scale is the 30. So now print that transition matrix. So now it show about that all of classes 101 how much pixel number, 102 how much, 103 how much, 104 how much, then 201 how much. So all of those things we get from here, you can see as a dictionary. So just click on here. You can see, you can find out the 16 properties. Okay, and here you can see about that 101, 102, 103, how much pixel number, 104, 201, 202, 203, 204, 301, 302, 303. So all of 401, 402, 403, 404. and you already know about that what is the 101 means, what is the 202 means. Okay, so in this time before class and after class, water in 1991 to water 2021, how much? Water 91 to build up 2021, how much? Water to vegetation, how much? Water to barren land, how much? So we can get all of transition pixel number. Further from here we calculate the area, how much pixel area, it's called the transition area. So let's go try to calculate the area. Okay, so anyone any question about that, you can ask me for that. Any question? Okay, okay, okay. So now we calculate the area about that, how much you can get from here. So for that, just take a variable, suppose area image, and then I simply call this image.pixel area and divide with these things because I want to calculate the result in square kilometer, and add bands. I put here this March. Okay, basically it is stored all of 101 to 404. All of those things is stored in this here March. And further, we are just calculate the total area, all of area. Control and forward slash when you press, then it will be automatically uncomment same time. Okay, and further just print that. So now you can see this result properties. We can get this type of value. So click on here. Here you can see about that is class, how much area you can get it. 101, how much area? 0.6 square kilometer area. Then click on here, you can get that how much area for, you can see 102, how much area? 0.0059 square kilometer area. Further click on here, we can get the result, you can see 103, how much area? 0.0015. Okay. Also click on here, then all of transition area it calculated. 104, how much area you can get that? You can see 0.00463. So all of transition area it calculated from here. 402, how much area? 61.29 square kilometer area it calculated. So it's a transition area. If you want, you can also make the chart, but sometimes that does not work. So then we have to put here this type of things. Okay. So in this time we talk about the another concept. So in this time you can see here it's very popular concept for that data visualization in Google Earth Engine. So in this time here you can see it show the list look like that 0, 1, 2, 3. Okay. So you can see 0, 1. So it's the list, and when I open the list, then we can get further another list. Okay, another list. So this type of list called the nested list. Okay, but if you want, you can just make the nested list in the plot list for the data visualization. So for doing these things, we also add the flatten function. Okay, suppose in this time we can click on, we can get it's this type of list. It's one kind of list. Okay, so it's called the nested list. Suppose 0, 1, 2, 3, I have a list, and when I click on here, then I also get the another list. So this type of list called the nested list. So we can easily convert the nested list into flat list using the flatten function. Okay. So let's go try to discuss about that, how we can really do. And it's also important for that land use land cover map. Suppose here you can see we already create this type of map, but we are not make this. We calculate the area using the chart things. Okay, but it also possible to calculate the area at the same time all of classes. Okay, because sometimes chart is not work. So for that we have to follow this process to make the area, calculate the area randomly. Okay, so let's go try to show you that how we can easily apply the flatten function and also calculate the this type of area without creating the chart. That is also okay for the small study area, but when you want to work for the big study area, sometimes we have some limitation on the chart. So for that we have to follow the another process to create this things. So just I will show you that. Suppose I want to make the suppose just calculate the area. Okay, after showing that, just we are back to the change detection again. Suppose calculate the area. Take a variable. Suppose I put the variable name is that LULC area, and then call ee dot image dot pixel area, and these things I want to suppose divide with 1e6. Further I can get the result in square kilometer unit, and put here add bands, and call this land use land cover variable name. Okay, you have to find out this variable name. What is the variable name? So here you can see this variable is that classified. Okay, I simply copy because I put the classified variable stored this land use land cover map. So just I put here add bands. Okay, now further take a variable, suppose area, and call this LULC area just here, and then use a function. This function called that reduce region to calculate anything specific boundary. So now put all of argument one by one. So just I make a dictionary. So curly bracket start and also curly bracket in. So further here you can see about that. So reducer, I am to calculate the total area. So ee dot reducer dot sum. Okay, and now we calculate the total area not for single class. Okay, in this time we calculate the total area for all of classes. So all of classes we need to make a group. So for that just use a group function. Okay, we create a group. This because we already know about that for calculating the area for the single class. Here you can see in our code we already write the code for the single class single urban class we already calculated. But for that we are not put here that group function. Here you can see. Okay, we can see a single urban class 2021 we are not put the group function because it's just a single class. But when you want to calculate the multiple class, then we have to put the group function. In the group function we need to define the two things, group field and group name. So just I put the dictionary and put here two things. If you want, you can also put the directly value. Also, there is no problem. I just put the dictionary and keyword and key value. Suppose group field, I put the one only for the one field, and group name same as your property name. So here you can see property name is the class. This same name we are also put also in here for the class. Then geometry, it's our shapefile variable name which says ROI. Yeah. Scale is that 30 meter for the land set imagery. Other things not to remove that. Okay. So now at the same time it calculate the area. Okay. Suppose I just try to print that and what happened. Suppose this print the area. So print this. Click on. So now it computed all of area in square kilometer at the same time as a nested list. Here you can see it compute the dictionary as a nested list. Okay, just click on here. You can see, just click on it, you can get that this type of list. Click on here, then we can get this type of value. You can see the same process. You can see 0, 1, 2, 3. It's one kind of list. In this list, when I just click on here, then I can get the another list, class and sum. Class 0, how much area? Click on here, then I can get that class 1, how much area? Click on here, I can get the class 2, how much area? Okay, and finally you can see, click on here, class 3, how much area we can get in here. Okay, unit is the square kilometer. And what is the 1, 2, 3? We already know about the 1, 2, 3. So in this time you can see I can get this type of nested list. So now this nested list I want to convert into plot list. Okay, so for plotting these things, just we are use this code. Suppose here, and in this time we also get the same process. You can see 0, 1, 2, 3. Click on here, then I can get the another list. Click on, I can get another. So it's called the nested list. So this type of nested list we convert into flattened list. So then our data is the more better visualization. For doing this thing, we are just use this code. Now click on this time, you can see what is the difference between these two results, nested list and flat list. So now here you can see, just click on here. In this time, we can get the plot list. You can see directly we can get the value 101 how much area, 102 how much area, 103 how much area. So directly we can get all of result, all of area, transition area. But first time you can see, without that we are just make the groups and we can get this type of nested list. Okay. So now the same things we also try to apply in our land use land cover map. So that's why you can get the result. Suppose directly we can get, suppose 0 how much area, 1 how much area, 2 how much area. Okay. So in this time it shows this type of things, but when you apply this code, then we also get that flattened list. So further we are just use the same code also in here. So just simply copy from here. Just paste. So now in this time, whatever you can see, in this time, we are just make a list. Okay, just make the list, call this variable name area and get from the group. And further, we are just make a function. In this function, first of all, we create a dictionary and also create the two things. One is the class number or class value, another is the total area. So further, you can see class number, we get from the class number and also get from the area. And further, it also, and this time the area dict, it's come from the transition, it's come from our property name. So in this time we put here the property name, which is, you can see, click on here, you can get it, class. Okay, just put here the class. And further it also okay, there is not need to change. And we calculate the total sum, you can see also put the sum area. And now click the run. And this is a function about the flatten. Basically this function help you to convert the nested list into flattened list. So now further check the result. So click on here. Now we can get the, we can see about that 0 how much area, 1 how much area, 2 how much area, 3 how much area. Okay. So basically at the same time we also calculate all of area. Further we can get this type of nested list, okay. But further when I use the function and further use a flatten function, then we can get this type of result at the same time. Okay, and it's very neat when you want to work for the big study area. Okay, sometimes the chart is not work well, then if we just calculate the area randomly, this type of way. So you can easily got this idea how it will be work. So now come back to the section. Okay, so we can get this type of area for the change detection.